Again, high strength concrete, high performance concrete is very essential part in terms of the construction planning. We spent about 2 months in Dubai at the beginning of the process, focused mostly on the concrete work. How do we get everything that we have to get? So essentially we mix design for high strength. It has to satisfy the mechanical properties such as the compressive strength and modulus of elasticity. Mass concrete, anything that's very thick, could generate very high heat, and we have to be careful with the curing methods. So we wanted to create a mix that has generate low heat of hydration, and also we considered high volume fly ash in some areas. Achieving a very high strength in order to achieve the 3-day cycle was also very important. High pumpability, high flow concrete was also required to make sure that we can pump that height without getting any segregation problem. It was very essential. And also high durability concrete requirement is also very critical. Some of the tests that we had done before we started any construction whatsoever is a creep and shrinkage testing, evaluation for creep coefficients in order to understand exactly what the behavior of the concrete is, what impact it has on the vertical deformation and also lateral deformation of the tower. And we conducted 2 types of tests, one done at CTL in Chicago, and the other one was done at Samsung Laboratory as a supplemental test. And the results were very close. We also did the pumping simulation test for about 600 meter. And we wanted to test all the concrete characteristics at the beginning of the pump and at the end for strength, modulus of elasticity, to make sure that there is no segregation problem. And essentially through the entire run, potentially we increased the temperature of the concrete by about 5 degrees. So we had to be careful with the initial temperature at deposit. Site mock-up test, we have very large column. It's about 2.1 meter diameter, and Dubai has between day and night is up to about 20 degrees centigrade temperature differential. So we had to be careful in terms of the temperature differential between inside and outside. And essentially we did also a full mock-up test for all the column, and the pull-out test for evaluate in-situ strength and a heat of hydration test. So what you see here is the curing methods. We also tested what type of a curing method do we use. So we investigated all type of curing methods for proper curing for both vertical and horizontal members, for the walls, for the columns, for everything that we could think of, just to make sure that there is no a cracking that happened in the concrete during construction, which many projects that you will see, even in the state, is very difficult to control sometimes. And mass concrete, we have very large elements in which we did a lot of testing for that. Investigated the curing compounds for horizontal members such as the slab and the beams. And also for the podium, we used the curing compound and water ponding as much as possible, especially in the parking garage. Hot weather concreting, we needed to do special plans, such as to control the concrete temperature, chiller plant, ice shelters, and aggregate, normal concrete mixing at about 31 degrees, mass concrete mixing at 28 degrees for any members that's less than 1.5 meter. For members that are exceeding 1.5 meter, we had to limit the temperature at 25 degrees centigrade. And also we tried, especially in the summertime, to do all the concreting at night when the temperature is not so high. And the quality control, we essentially had a monthly test report for raw materials, cube strength, and a quality control procedure for batching and so on and so forth.